Okay, we are almost done, guys. I know it doesn't seem like it, but we're getting there. Okay, we are on 5.3 exponential and logarithmic integrals. Honestly, I don't think we have that much more left. We'll end with trig, and then you'll take a test, and then you are completely done with calculus. Come on, we can push through. All right. So, got 12 problems, examples for you to do today. 12. Please bear with me. Don't lose me. Okay? Exponential integrals. If you want to take the integral of e to the x, remember the derivative of e to the x? It was e to the x. The integral of e to the x is e to the x plus c. Wow, that's it. Yes, same thing. Well, what if that x, though, has like something else? Like if it's x squared plus 2, or if it's 3x, then you call that the u, and you then have to make sure the du, the derivative, is inside this integrand. Then you just write it as e to the u plus c. All right, so we're going to practice some of those. So I've written down about 5 examples of the e's. Let me move this. So let me show you what I'm working with here, okay? This is a constant 2. My properties say I'm allowed to pull that constant out. And then I have the integral of e to the x dx. And again, from up here, the formula, the integral of, if it's e to the x dx, you just have e to the x plus c. Well, with that 2 on the outside, you would just have 2 e to the x plus c. That's it. Done. But if I don't have an e to the x, if I have an e to the 2x, like this one, then that becomes a u. And you have to look to see if the derivative is inside. So you have to do the whole u du dx thing. What I mean is your u would be 2x. Your du dx would be the derivative of that, which is 2. Multiply both sides by dx. Is 2 dx inside of this integral? Well, look at right there. I'm going to replace that with du. So then I have an integral of e to the u, eu, and then this part, I kind of scratch it off and write it as du. So what's the integral of e to the u du? Well, the formula says it's e to the u plus c, which is really e to the 2x plus c. Done. I mean, think about it. If you took the derivative of this, it would be e to the 2x times the derivative 2. 2e to the 2x, 2e to the 2x. So the integrand has to contain the chain. That's why. All right. If you understood that, let's keep on moving. Integral of e to the x plus x dx. So I can just integrate each one separately. So the integral of e to the x is e to the x. The integral of x, and we got to add 1 and divide. So that would be x squared over 2. And then put plus c. All right. What about e to the 3x plus 1? Well, this is definitely a u. So let's do our whole u du dx thing. U is 3x plus 1. Du dx is 3 multiplied by dx. So du would be 3 dx. I do not have a 3. So what do? I divide by 3. So I get 1/3 du equals dx. What does that mean? That means this right here, I'm going to replace it with 1/3 and a du. This, I'm going to write e to the u. The integral of a constant, that constant can just be pulled out to front. So the integral of e to the u is e to the u plus c. With the 1/3, it would be 1/3 e to the u plus c, or 1/3 e to the 3x plus 1 plus c. Okay, let's try it. One more. This is definitely my u. Let's take a derivative. negative 2x dx. I do not have a negative 2, but I do have an x and I do have a dx. So let's bring that negative 2 out in front, divide it. It'd be negative 1/2 du equals x dx. So this part right here, scratch it out, call it negative 1/2 du. So negative 1/2, leave a space, du, e to the u, and then this 5 gets multiplied there. So that's really the integral of negative 5/2 e to the u du. Well, again, you can take that negative 5/2 on the outside, and you can just take the integral of e to the u and put plus c. So negative 5/2 e to the negative x squared plus c. Okay, so that's the e's. Pretty simple, I think. It's kind of like the derivative. You just write it again, but you put plus c. Make sure you find that derivative inside. All right, now, logarithmic integrals. Ooh. So this is when you see fractions. If you see like anything with a u on the bottom that's above an exponent of 1, like squared or 3 or whatever, you can rewrite that as obviously a negative rule. But if it's to a 1 power, if your u on the bottom is to a 1 power, look at what happens here. You can't take the integral of that because if you add 1, that would be 0. And divide by 0, that doesn't make sense, okay? So anytime you have a squared or a cubed on the bottom, that's okay. You can call that u. But if it's a u to a 1 power, then you take the ln of it. It's the ln of u plus c. Okay? So let me show you in some examples what I mean. Write this down. Again, you can pause this, write this down. Watch me do a few examples. So if I take the integral of 4 over x dx, so that would be, again, that 4 I can pull out. So that'd be 4, take the integral of 1 over x dx. The integral of 1 over x dx, you just write it as ln x plus c. So this right here is ln of x plus c, and then multiply by 4. Easy peasy. The integral of 2x over x squared dx, well, again, you could simplify this first if you want to. This would be 2 over x dx. And then pull out that 2. And that would be 2. This again right here is ln of x plus c. Easy peasy. But now we get to something like this, 3 over 3x plus 1. All right, so let's notice something. This is what I could use as my u. It's not raised to a power, but I'm still going to call it u. 3x plus 1. My du, my derivative of that would be 3, and then divide by dx, so multiply by dx on both sides, 3 dx, which is right here. So this, if I were to go rewrite this, watch what I'm doing, okay? The u would be on the bottom. This would now be du. Now you could put the du on top, but I like to put it out on the side. And this would just be 1. So I'm integrating 1 over u du. 1 over u du. And the integral of 1 over u du, again, would be the ln of u plus c. The ln of u plus c, or the ln of, what was my u? 3x plus 1 plus c. All right, so let's do that again. 6x over x squared plus 1. What do I make my u? Probably the bottom. Let's try it. The du would be 2x dx. Well, I've got a 6x. Well, 2x, if I multiplied by 3, would be 6x. So this is really 3 du's. So this right here, cross it off, that is your 3 and your du. This is on the bottom as a u, and you put a 1 there. And now you integrate. So what would happen? Well, that 3 would kind of come outside. This right here, this is the same as the ln of u plus c, and then you multiply by 3. So I would rewrite it now as 3 times the ln of x squared plus 1 plus c. Alrighty, that's very fast. I've got 3 separate cases to show you. Okay, very important. These are 3 problems that will be in your homework tonight. So please watch what I do for all of these. Okay, so we'll start with this last one. 3x squared plus 2x minus 1 over x squared. So if you're over a monomial, you're allowed to split that and rewrite this as 3 separate fractions. What I mean would be what? This would be 3x squared over x squared, or just 3. This would be 2x over x squared, or just 2 over x. And this would be 1 over x squared. Okay, so now I can take each one of these individually, the integral of each one. So let's see, what's the integral of a constant? Well, that's just 3x. What's the integral of 2 over an x with a power of 1? That's the logarithmic, okay? If it's just a power of 1, then you can rewrite that as the ln of x, and then that 2 is multiplied on the outside of it. What about 1 over x squared? Well, guys, that's the same as x to the negative 2, right? So add 1 and divide. So it'd be negative x to the negative 1, but there was already a negative here, so it'd be positive x to the negative 1, and then plus c. And then you can clean this up if you want to. 3x plus 2 ln x plus 1 over x plus c. Alrighty, number 11. This one, whew, I always forget this exists until I start seeing it again. When you have this like e's with ones and e's in the bottom and their quantities, there's a lot of different things you can do, but if you tried to make this your u and take the derivative of it, you would not get a derivative inside of here. So watch what I'm about to do. It's going to be crazy, and you're going to be like, really, you can do that? And yes, you can. Before I even start doing this problem, if I just multiply the top and bottom by e to the x, remember, e to the x over e to the x is just multiplying by 1. You can multiply by 5 over 5, by 1/2 over 1/2. But this e to the x over e to the x actually becomes important. So I would have e to the x over e to the x times this quantity. So e to the x plus e to the x times e to the negative x would be e to the 0, right? Which would just be what? 1. Okay, so all I did was just multiply by e to the x and e to the x. No big deal. Now, if I take this denominator and make that my u, and I took the derivative of it, the derivative of e to the x is e to the x, derivative of 1 is 0, multiply by dx. Notice what I've just did. I have my du right there. So multiplying by that e to the x was important. So now I have the integral of a u on the bottom, so a 1 over u, and then this part right here that I scratched off was my du. I like to put it out on the side. So what's the integral of 1 over u? 1 over u is ln of u, or ln of e to the x plus 1 plus c. Yeah, I remember this, and I always say to myself, I'm like, I would never remember how to do that. Just sometimes it's just as easy as multiplying by conjugates or multiplying by an e to the x on top and e to the x on bottom. All right, and last one, number 12. So you don't have a monomial here, you have a polynomial. So what do? Well, there's this little thing called long division. If you remember doing that, you would have x minus 1 into x squared plus x plus 1. I think we did it as synthetic division also. But what would happen is, again, you would say, how does an x become an x squared? Oh, you multiply by x. Then you multiply this to that and that. And then you subtract, change the signs. This goes away. This becomes 2x. Bring down. How does an x become 2x? Multiply by 2. You always do the first to the first. 2x minus 2, change signs, and you're left with the remainder of 3. And you would rewrite that as 3 over your quotient. Now, again, you could have done synthetic division. You would do -1. Actually, I'm sorry, you do +1 because you changed that sign into 1, 1, and 1. And bring down. And then this would be 1x plus 2, and then this is your remainder. So look, I got the same thing, x plus 2 plus 3 over x. So how did that help me? Why would I do that? Because now we're going to integrate this separately. Integral of x dx, the integral of plus 2 dx, and then the integral of 3 over x minus 1. We're integrating each one separately. So the integral of x, add 1 and divide, would be x squared over 2. The integral of 2 is 2x. The integral of this one, this is your u. Your du, derivative of that is 1 dx. I have a 3, so you can call it 3 du. Or you could pull that 3 out in front if you want to. But it'd be 3 times 1 over u, which is the ln of u, plus c. Okay? All right. Lots of things you're going to be working on page 342 tonight. And then tomorrow we're going to work on more of these. You're going to have a worksheet to do on all of them. So sorry for how long this is, guys, but I know you can do it. We're almost done. We're almost done. You got this. See you later.